Hey ladies and gentlemen, we're going to do 2.5 today on graphing linear inequalities and absolute value equations and inequalities. We have seen graphing inequalities before. This isn't anything new. So just remember when you do this, if you have a less than or greater sign, that you have a dotted line. And when you have a less than or equal to or greater than or equal to, you have a solid line. Okay. We also do some shading. So when you're on the top of your page, on the top of your notes, I want you to add this part too. You're going to shade up. Woo, moved on me. Oh, that's not where I wanted to go. Hang tight. There we go. I lost my shaded or solid. Okay, so when you have, you're going to shade up. So above the line, when it's a greater than or equal to, and you're going to shade down when it's a less than or equal to. So those work only the y needs to be on this side, or the just the y for that to work. Okay, you should remember that from last year. So let's go ahead and look at this first one, and we have a little note here that says identify the intercepts in the slope to help us graph. Really, we just need the intercepts to help us with graphing for most of it. So this is in standard form, so I'm going to use the cover-up method that I talked about before. So if I'm finding my x-intercept, my y-coordinate in my x-intercept is 0. Okay, so if I was to plug a 0 in for this y, that term goes away. So that's why you can't see me, but I'm like covering it up with my hand. So you end up with this 2x, and I'm just going to change it to an equals. So if I divide by 2 on both sides, I find that my x equals 3. This is for that spot there. So this is our ordered pair. That's our x-intercept. Okay. Now in my y-intercept, my x term is 0. And so I'm plugging a 0 in for there. Or again, I'm covering up the 2x. So now I have 3y equals 6. So I'm going to divide by 3 on both sides, and y equals 2. So I go up to 2 and make my point. So now I have my two intercepts, so I can easily go ahead and graph this then. So it also asks you for your slope. Super simple, we can just go ahead and count our slope from our graph. So my slope is up 2 and over 3. So up 2, oh sorry, let me erase that last line. Let's try this again. I'm going to go up 2 and to the left 3. So 2 over -3 or -2 over +3. Both of those are acceptable for your slope. Now, is this a solid or a dotted line? Well, my inequality sign has no line, so it should be dotted. So you can just write dotted next to it. And then, oof, this one is where it's hard. I got to decide shading. So I can either solve it so I get my y all by itself. So I would subtract my 2x to both sides. So I have 3y is greater than -2x plus 6. Divide by 3 all the way across. I get y is greater than -2/3 x plus 2. So I'm going to shade above. But another way I could do this, I'm going to show you, is test point. So I'm going to use a test point. So this, I'm going to use 0, 0 because my line doesn't go through it and it's super easy to use. So I'm going to plug 0, 0 in for x and y. And I'm going to solve this inequality and see if I get a true statement or a false statement. 2 times 0 gives me 0. 3 times 0 gives me 0. 0 plus 0 is 0. So question, is 0 greater than 6? No, it's not. So this is false. So when it's false, you shade the opposite side of the line from where my test point is. So if my test point is here at the origin, that tells me I need to shade the opposite side of my line, not where my point is. So two ways to determine shading. I don't care which way you use. All right, so here, again, it's in standard form. So find the x and y intercepts using cover up, or you can solve it so it's in your y's, y equals mx plus b form. I'm going to have you guys pause the video here and try graphing it on your own. Okay, so I did out the problem for you. X and Y intercepts, the slope. I converted it here into slope-intercept form if that made you feel more comfortable. It told me I was going to shade above, or I could plug my test point in of 0, 0, and I end up with 0 is greater than 4, which that's a false statement. So that means I shade away from my inequality. All right, Manny has $15 to spend at the fair. The cost is $5 for admission, 75 cents for each ride, and 25 cents for each game ticket, and write an inequality for the number of ride and game tickets he can buy. All right, so we want to write that inequality. So it costs him $5 for admission, plus 75 for each ride ticket. So I'm going to call that like R. And 25 cents for each game ticket. So let's call that G. Okay, and he only has $15 to spend, so he can spend less than or equal to $15. So I want to kind of clean that up a little bit. Oh, I forgot my G in there. So I'm going to subtract 5 over. And I have 0.75R plus 0.25G is less than or equal to 10. All right, so if he buys 10 game tickets, how many ride tickets will he be able to buy? So we're going to plug 10 in for G. So 0.75R plus 0.25 times 10, because that's where G is less than or equal to 10. Okay, 0.75R plus 2.5, that's what 0.25 times 10 is less than or equal to 10. Subtract over your 2.5, so you get 0.75R is less than or equal to 7.5. So he can ride 10 rides or less. What's the maximum number of ride tickets he can buy? So we're going to assume that he is going to do no games then. So 0.75R plus, we're going to say 0.25 times 0 because he's not going to do any games. So this term cancels. So we have 0.75R is less than or equal to 10. All right, so take 10 and divide it by 0.75, and we get R is less than or equal to 13.3 repeating. Well, you can't ride a third of a ride, so then we would say the maximum number he can ride is 13. He can't ride more than that. He's going to have a little extra money, though. That'll be nice. What's the maximum number of game tickets he can buy? So this assumes he's going to do no rides. So we're going to plug 0 in for R, plus 2.5. G is less than or equal to 10. So now we have, this term is going to go away, so you have 0.25G is less than or equal to 10. Go ahead and take 10 and divide it by 0.25, and you find 40. So, come on. 40 is the most he can, games he can do, and he's going to have no money when he's done with that. All right, so just a little with the inequalities. All right, so absolute value function shifts. What's the inside of the absolute value with the x? Shifts it left or right. We talked about this in 2.4. So you're going to set the absolute value bar stuff to equal to 0 and solve for x. That's our x coordinate. We also talked about that in 2.4. Anything on the outside is what's going to tell you what moves it down. So that's your y coordinate. So if we look here, so we want opposite of what's inside is my x coordinate, and whatever is on the outside is my y coordinate. So my vertex, -5, 7. Just a reminder from our notes on 2.4. Whoops, too fast. Okay, so graphing these equations, then we'll get to inequalities. So this is review from 2.4 when we were together. So x plus 1 minus 2. So my vertex is going to be opposite of here for my x, And the same is here for my y. That's my vertex. So now we make our xy table to help us with that. X, oops, y. So if my vertex is at -1, I can go -3, -2, -1, 0, 1. But remember, these values are going to be the same, and these values are going to be the same. So, gotta go back up here. I'm going to plug in to my function here. Now I can plug in either -2 and -3, or I can plug in 0 and 1. And I'm going to pick 0 and 1 because those are easier numbers to plug in. Don't you think? I think so. All right, so absolute value of 0 plus 1 minus 2. 0 plus 1 is 1. The absolute value of 1 is 1. Minus 2 gives me a -1. So that's going to go there. I'm going to plug in 1. 1 plus 1 is 2. The absolute value of 2 is 2. Minus 2 gives me a 0. So these are going to be the same. So now I'm going to graph it. So -3, 1, 2, 3, 0. -2, -1. -1, -2. And then it's mirrored on the other side. So that's just review. Woo! All right, that's just review from 2.4. So we have another one like this. I'm just going to get you started with your vertex is at 4, 1. So I'm going to pause the video here, and I want you to pause it here, and then I want you to graph this one. So when you come back, this one will be graphed for you. All right, so go ahead and compare yours with mine. Hopefully you got to the same thing. If you didn't, make sure you make a note to ask me questions about it when we're back together in class. All right, so now that brings us to graphing inequality absolute values. These are going to be the same way that we did our other one. So just start off with opposite of what's inside my absolute value is my x for my vertex. Well, there's not a plus or minus there, so that means that my x coordinate then is, yep, you guessed it, it's 0. My y coordinate is whatever happens outside. So here's my vertex. So everything I'm doing so far is the same, all right? All right, so my vertex, I'm going to pick -2, -1, 0, 1, and 2 because my vertex is here. So these ones should be the same, and these ones will be the same. All right, so I'm just going to plug in my -2 and my -1. It's really not much difference in this case. All right, so the absolute value of -2 is 2. Then I have to multiply that by 2 here, so I get 4. 4 minus 3 gives me a 1. Right? Now I'm going to plug in -1. The absolute value of -1 is 1 times 2 is 2 minus 3 gives me -1. So I'm going to go ahead and just graph my points. -2, 1, -1, -1, and 0, -3, 1, 2, 3. And I'm going to mirror it over here. Now, don't just go jump to writing a solid line. This is inequality. So here, if we look, I'm going to have a dotted line. So you can either make it dotted or you can draw a solid and state that it's dotted. Now, instead of saying above or below, we're doing inside or outside. And so I can see that my y is on that side. So that means I'm going to shade inside here. So absolute value inequalities, not much different than graphing an absolute value equation or a plain old inequality. All right, so go ahead and make sure you do your 2.5 worksheet, and we'll see you guys later.